Welcome to Walkabout the Galaxy, the whimsical astronomy podcast where the science is universal, the opinions are personal, and the points don't matter.
Woo!
We are strange, charmed, top and down the astroquarks, also known as Josh Caldwell.
Addie Dove.
Jim Cooney.
And Audrey Martin.
Coming to you from the Walkabout studio at the University of Central Florida, and one light second away, Jim Cooney.
Yeah.
It's so bright where you are right now.
Yeah.
Follow us on Instagram and anywhere else we may happen to show up, but mainly Instagram, where the facts aren't checked and stories like our collective memory only last 24 hours. But they can be liked, so like away and tell your friends to listen to the best podcast. And check out Walkabout the Galaxy. Catch our videos on YouTube. We are at Walkabout the Galaxy. You can email us at wtg@ucf.edu. Our stumper today is temporal spatial travel.
Travel?
Yeah.
Got it.
It's for Jim.
We haven't had one of those in a while.
Right. If you could visit any world in the solar system, including Earth, and hang on a second because there's a twist.
Wait till the end.
There's a twist. Any world in the solar system, including Earth, as a space traveler, you arrive in a spaceship, you can land, you can do an EVA, you've got spacesuit, whatever you need to do an EVA on the thing. 4.4 billion years ago.
Oh.
Where would you go and why?
4.4.
Is that before
the Nice shuffle? It is before the Nice shuffle.
Can we make a dance called the Nice
The
Shuffle
Nice
and
Shuffle.
submit it as our
I
next
like
Instagram
that.
video?
Ooh, ooh.
This is our
Yes.
next video. We'll
We
do
do-
the Nice Shuffle.
We do an Instagram video every 4 years.
It's gonna be
this would be
perfect.
great. Yeah.
Great.
Jim did Sad Mercury. Jim did a Sad Mercury TikTok dance.
That was genius.
And so, so the next one could be the Nice Shuffle.
Yeah, I think I want
That
to
is
be
a
like
great
Uranus or Neptune or something then.
Okay, you're going to go to Uranus or Neptune?
Yeah, because they're going to be closer in.
Right, but will you be able to tell that?
Yeah.
It'll just, the sun
I'll
will
just
slam
know.
slightly
The sun will be so much brighter.
from Uranus than it is now.
Yeah.
And you know that from your previous visits to Uranus and
Yeah.
its current location?
Yep.
I see.
I don't know. How long do we get to stay there?
1 week.
It'd still be cool. I still,
Okay,
from like a
going to Uranus.
scientific interest
Maybe it
perspective,
hasn't
I
been
still
tipped
want to
over
do
yet.
that. Yeah.
Maybe you could tell whether...
Maybe it's
it
got a
hasn't-
totally normal magnetic field. Maybe it hasn't been tipped over.
It may not have rings.
It may not have rings,
May not
or may
have
have
the same
huge
kind of
rings.
moons,
Who
or
knows?
something completely
Who
different.
knows?
Right. Okay.
I'm thinking Mercury.
Yeah, boring.
To see if it's had its surface splashed
Yeah,
off
to
yet.
see if it has a different surface. If maybe it's bigger or different in some way.
It's maybe not a naked core.
Yeah, maybe
Naked-
naked mantle.
Naked
core?
Mantle. Naked Mantle could be the band that is playing for the Nice
For the Nice
Shuffle.
Shuffle.
Oh, that's
I
so
like it.
hardcore.
Yeah.
Yeah. Jim, what about you?
James.
Earth.
Yeah.
Yeah, I was going to
Sure.
say
I
Earth.
mean, I included it deliberately because
Yeah.
you know,
Well, I don't know. It's just because that's the terrestrial or the planet that we know the most about now. So it'd be nice to have some information about it then, because then you could connect some dots.
Sure.
I know that's a boring answer, but I
Really
want
boring.
to know what it was like back then.
yeah. I suppose I think I'm contractually obligated to say Saturn.
You are. Yeah. You'd find out if the rings.
See what's up with
What's
the
up
rings.
with the rings?
Were there rings then? If there were, do they have any connection or resemblance to the rings now? Also the moon, because there's this whole thing about Saturn's rings basically sort of spalling material off the outer edge to form some of the small moons.
Oh.
So I'd have to do some serious work during that week
Sure,
in
yeah.
orbit to
Oh, yeah. There's be a lot of
a
preparation.
lot of scoping out.
Do we get to take like modern scientific instruments with
Yeah.
us? Yeah.
You
What
got
about
the whole
futuristic?
thing.
Futuristic.
Great.
Sure.
Scientific. Yes.
Cool.
Let's say
Great.
you have like the Starship Enterprise.
Oh,
Perfect.
So you can do
Do we get to bring that data back to us in now time?
Do we also have data?
That's just such exciting.
data.
Android?
Oh, yeah, the
No,
Android.
you don't have data.
I
No.
don't
You'll
wanna
have to do
it
your own
anymore.
scanning for life forms.
Scanning.
Fine.
Scanning.
Yeah.
Cool.
Today we'll talk about changes in Venus, changes in dark energy, and much more. But first, this episode of Walkabout the Galaxy is brought to you by Europa's Ocean.
Ooh, deep. Huh.
Palm trees and white sandy beaches are for yesterday's vacations. Find the future with a stay at Europa's Ocean. Conveniently located in orbit around Jupiter and protected from harmful radiation by an icy cap of 10 kilometers thickness, Europa's Ocean offers an abundance that goes beyond anything Earth can offer, with more water than all of Earth's oceans combined. With a submersible, you can circumnavigate Europa in this global ocean, all the while enjoying Europa's famous reduced gravity of just 1/7 Earth gravity. Sail the salty seas of Europa and search out hot spots on the ocean floor and sample the water for microbial life. Europa's ocean not responsible for transport through Europa's ice shell, lighting, air, food, or heat. Europa's ocean, journeys to the extraordinary.
The Bahamas.
Journeys to the extraordinary.
Alaskan cruise lines or Norwegian
Closer.
cruise lines
Yeah,
or something.
Jim?
Yeah, I was gonna say just that, like Norwegian cruise lines,
Yeah.
because that's European.
I'm going to give it to you both. It's Viking cruises.
Ah,
But, yeah.
that was the one I could.
yeah.
I would love to
I
do
like
one
it.
of those. I think a Viking cruise. They seem
Yeah.
really nice.
I mean, you still can.
Well, it requires
Oh,
like
like a
money and
river
time
cruise.
commitment. Yeah.
You
Yeah,
have
those
you
do
have
sound
time in
fun.
front of you, and presumably you'll have money in front of you too at some
Sure,
point. Yeah,
sure.
could do one of those things. Space news. We mentioned Fram
They splashed down today.
2 was
Oh.
had just taken off when we
Yeah.
recorded our last episode, and they just splashed down in the Pacific Ocean.
Which is
Can
the
we
first
still call it
time-
that?
I think that's allowed.
Okay.
Yeah. That's the first time there's been a human splashdown in the Pacific Ocean from SpaceX.
Did
Right.
everything go well?
Yeah.
Oh, that's great.
Yep.
They were supposed to do some interesting thing where they got themselves out of the capsule, and I didn't see if they ended up doing that. It was like
How would
there'd
they-
be something where they practiced like getting themselves out of the
Sort of an
capsule for the
emergency
first time because
escape
it's
or
an
something.
emergency escape because it hadn't been practiced yet.
Oh,
But I
okay.
didn't see if it happened.
Yeah. The splashdown, I find the ocean. I find scary.
Just
Big.
in general.
Yes.
Yeah.
Yeah. So the splashdown part is like you're in this.
Gus, you don't want to be Gus Grissom.
No.
It's bad.
Yeah. So
Right, Audrey?
And I know why.
His capsule didn't open. Or it
or
started
he
leaking.
maybe prematurely pops
Yeah.
the hatch or something.
I know.
It went down.
Yeah.
I know.
That capsule is now at the Cosmosphere.
He had a somewhat ignominious capsule.
Ooh, that's a good word.
We
retrieval.
say that he haunts the Cosmosphere.
Yeah.
Let's see. Other space news. J-Dub. This is observatory / space
Oh.
news. That was a mix of news and observatory sounds. J-Dub caught a snap of YR4.
2024
yeah.
YR4.
Exactly. That one.
yeah. Oh, yeah.
2024 YR4.
The one that
That's kind of amazing. So
Yeah.
2024 YR4 is this little, not so little asteroid that for a brief window in time had a like 2% chance of hitting the Earth in a few
It
years.
was 3. It has got up to
Yeah, it
3
got
at
up
one
to
point.
3.
Now
Yeah.
it's like
I just saw a thing that the chance of it hitting Earth is now very, very small, but the chance of it hitting the moon is now up.
which would be
No
like
way.
the
Like that.
best.
That's
That would be
ridiculous.
badass.
that would be amazing. Oh my god.
I did hear something
That would be
about it
cool.
hitting potentially hitting the moon, and I was
Could
like,
you
that would
imagine?
be so cool
That would
Yeah.
be cool.
because we could
but,
study it so hard.
Yeah.
But that's ridiculous.
Why?
Why?
Well,
Because
the moon is
moon's
a
so
smaller
small.
target.
Sure.
It's 4 times
still
smaller.
in a vicinity where the asteroid could
yeah,
go.
yeah, no, I know. I'm just saying.
What if we pushed it a little bit closer? Like changed its orbit
What
a
if
little
it
bit so
changed
that
the
it
Earth,
does.
the moon's orbit?
Yeah.
It's like a mini dart.
Yeah.
I don't want it to
Experiment.
hit. I don't want it to hit the tardigrades that live up there. So
It could hit. There's very many places on the moon. It probably wouldn't hit the
You don't
tardigrades.
want it to hit the
Okay.
tardigrades living on the moon.
I don't want
Yeah,
it to
yeah.
hit the astronauts living on the moon by then either.
Yeah.
oh yeah. Oh
2032.
yeah. I forgot
2032.
that's-
Or any of the like
It's the
rovers.
2032 flyby that they're talking about
I think that's
for
when
the
it would
potential hit.
Yeah.
Yeah, because I
okay.
think the
2028 is the next time it's close, and
Yeah.
then 2032 is when
Right.
it would smack.
Oh my god, that would be
Well, I'm
amazing.
rooting for it.
Yeah.
Yeah.
That would be
Ooh.
good. That would be an exciting thing to see, and we would learn a lot about cratering
Yeah.
from that because we would know
And
how
the
big this
composition
thing
of that
is.
thing, and like,
Oh,
my
yeah.
God, so
Yeah.
much. We could probably put stuff down on the moon beforehand to like capture the volatiles.
What if it kicked up enough rock that it made more near Earth asteroids and we
Yes.
saw
like we were talking about with those little
Yeah.
ones. Yeah. Oh my God. We're so excited by this now.
yes.
Yeah, but
Yeah.
what
Let's make it happen.
what
Let's
i-
make it happen.
What is the current estimate
I
of the
don't know.
probability? I mean, it's got to be still.
It was
pretty-
something like 3%. I thought
Again?
I saw.
Really?
Hitting the
3.
moon.
That's
Yeah.
Pretty good.
shockingly high.
still also
is
like
shockingly
probably,
high.
probably
I
won't hit it.
Yeah.
That's what I
14
thought I
hours
saw.
ago,
Yeah. Okay.
Chances of it hitting the moon increased.
Don Pettit. Do you know Don?
He's great. I have met him.
I met him so many years ago, and he had already flown
Yeah.
in space at that time, and he's up there again or
I
something.
know. I was so shocked when I heard he was flying again.
Yeah, I thought that he was like the old generation of astronauts or
Yeah.
something, but he's up there and he took pictures of sprites that are pretty cool.
He also did a fun video of him getting into his pants on the ISS.
That-
He like had the pants hanging and then he dropped down into them. He's been doing lots of cool actual science videos, but other fun videos like that too.
yeah.
Yeah, he took pictures of sprites.
He's somewhat famous for sort of being an experiment tinkerer on
Yes.
the ISS. He did some experiments with like Ziploc bags of coffee grounds and sugar and salt and stuff like that, and shaking them up and seeing how the particles interact with each other. So like a $1 science experiment
Yeah.
on the $100 billion space station or whatever. Yeah. Any others?
Yeah, 3.8% is the chance of it hitting the moon right now.
Amazing.
And that's up because of the data from JW.
Okay.
They did find out that it's slightly smaller. It's 53 to 67 meters as opposed, but it's also,
okay.
it used to be 40 to 90, and now they think it's 53 to 67. So they have a better size estimate.
Does that mean they have a better compositional
I
estimate?
didn't see anything about I mean, it's JW,
Well-
so
Well,
probably
brightness,
not.
If they
I
have
guess.
that size coupled
Yeah.
with the brightness, that's going
Yeah.
to give them a little bit better
bit.
estimate
Yeah.
of the reflectivity.
Yeah,
but,
yeah.
If it did hit the moon, it would not change the moon's orbit.
Well, that's
It's
good.
pretty tiny, which is good, yeah. But anyway, okay.
Yeah.
Oh my God, that's
We gotta,
so exciting.
More updates to come in 2028, probably.
Okay.
We won't get too
2020
many more updates after this because it's pretty far away now.
This is episode 391. So if you're a new listener in 2029 or something like that, I don't know how to do this. Mark your calendars now for
I will.
2028 episode
Yeah.
480 or something like
Yeah.
that.
Sure. Yeah.
Why not?
Yep.
There was another fun space news, like what's in the sky thing that happened this last week, where I think we talked, and it kind of ties to your sprites thing and the Fram mission.
Yeah.
Lots of interest in like what happens in polar regions and how do clouds form and how do atmospheric phenomena form. And there was a few episodes ago, we talked about there had been a SpaceX launch that had made a vapor trail and spirals, and people in Europe saw it.
Oh yeah.
But there was an intentional experiment from a sounding rocket that launched out of Alaska a week or so ago that like put a cloud of vapor into the atmosphere, and it made this like creepy, I don't know, eyeball halo looking thing that people could see.
Yeah.
And it was like 60 to 75 miles high with a diameter of 15 miles.
Oh my God.
And so they were studying how aurora make it into the atmosphere and how atmospheric effects cause like water molecules to boil and things happen. I don't know.
Cool.
Fun science.
Cool. Yeah. Any other space news?
Probably.
Let's talk.
Oh,
Nothing.
the Artemis 2 patch was just released.
Ooh.
That's cool.
Am I on it?
Yes.
Okay.
It's really
Were you-
subtle.
That is good.
Listeners, look for the hints about Josh on the patch.
It's subtle, right? It's an Easter egg.
It's just an Easter egg on there, but you can find it
You
though.
can piece it together. It's kind of like, listening to a Beatles song backwards or something. So it's the same
exactly.
kind of thing, right?
Yeah,
You
that's
have to-
good.
Yeah, it's cute.
Oh, Audrey found it already.
You just got to Google Artemis 2 patch.
I mean, it has the Earth on it.
right up.
Artemis 2 patch,
So-
hidden Josh Caldwell.
Oh,
Right.
I don't need to type that. I can see it.
You can see it.
Yeah.
There's good. We're gonna make one of those videos that's like 72 Easter eggs you didn't see in the Artemis 2 patch, and one of them is gonna
Okay.
be Josh.
Yeah.
Okay.
Caldwell.
All right. Sounds good. There's an update of Venus. Who loves Venus the most and wants to
Jim.
start us on that one?
Kidding.
I do love Venus.
Venus is pretty
Venus
crazy.
is really cool.
I thought about Venus in answer to our stumper, but
yeah.
because I don't
Who's
know, like
potentially
all of
going
them would
there?
be so interesting.
Yeah,
We have so
really.
many questions
4.4 billion years
about
ago.
everything about how our
Yeah.
solar
Yeah.
system formed, and Venus might have been like
Might have been a lovely place.
a lovely place. Maybe not 4.4. Probably like 3.5.
It might have been hellish in a different way.
It would have been hellish in the same way Earth would have been hellish
Yeah.
at that time.
Yeah, that's true.
So, Audrey.
Yeah. So there's a ton of volcanoes on Venus.
Right.
True.
There's the article says over 85,000, which is a
many.
lot.
That is a lot.
I don't
That is
know
crazy.
exactly how they're counting.
I think they did
many,
it the usual
but-
way, starting at 1. But
Oh,
you
not
don't
in the
think
middle?
they'd start at 0?
I think he started at 1. Is Paul Byrne? He probably started at 1.
Great.
True.
Okay.
Yeah.
Well, mystery solved. And one of the big questions with Venus is, why are there so many volcanoes? Why is it so volcanically active?
Right.
What is fueling it? What's heating things in the interior? And this new study is looking at the dynamics within the crust. So it looks like it's possible that there could be convection within the crust of Venus. So we have convection
Currently or previously?
Yeah.
currently.
What?
Yeah.
So we have convection in the interior of all terrestrial planets that on Earth drives plate tectonics and moves the plates around and all of that stuff.
Well, I mean, there isn't convection in Mercury. It's frozen out.
Sure, I guess there would have been.
Would have been.
Would have been.
Right.
When
And I
you
think
went to visit it.
When I visited it,
4.4
There was
billion.
convection.
Yes.
Right.
Great.
Yeah.
That's what was confusing you.
Yeah.
Yeah. Oh, now I see.
And I think similarly for Mars. Is Mars convecting in its mantle
Mars like
at
maybe
this
has a
time?
teeny tiny bit of liquidy
Yeah.
inside, but probably not much.
But
Yeah.
in the core.
Yeah,
so
but not the
deep,
mantle.
Deep.
Probably.
Yeah.
Yeah.
So, but once upon a time they did. But Earth definitely has convection in the mantle.
Mm-hmm.
And I think it's maybe worth reminding, because I had to remind myself,
Mm-hmm.
I get confused about crust, mantle, core, and lithosphere.
Okay, I've got this down.
Okay.
Nice.
Let's go geology.
Yeah.
Take it away.
So the lithosphere is
sphere of
lithosphere
rock.
and asthenosphere are defined based on rheology, or how rocks respond to stresses. So the lithosphere is brittle, and the lithosphere includes the crust and a little bit of the top of the mantle
for the Earth, for
the
example.
Earth. Yeah, for the Earth. And so if you're distinguishing things with crust and mantle, that's like essentially compositional. It's a compositional difference. So when we talk about the mantle convecting, we're talking about the part of the mantle that's in the asthenosphere. So the asthenosphere is convecting.
Right.
Yes.
Yeah. The crust, because it's brittle on Earth and it's pretty thin, the lithosphere doesn't really convect on Earth.
Well, and it's like, so the lithosphere is, as you said, it's the brittle part. So
Yeah.
it's hard to sort of reconcile brittle
With any convection.
Yeah.
convection. But we're not, so kind of what this is saying, correct me if I'm wrong, is that Venus doesn't really have a lithosphere. Its crust is part of the asthenosphere. If it is able to have convection going on in it, it must not be brittle, right?
Yeah, maybe. I don't know.
Crust,
I don't.
but it's
It's crust compositionally,
asthenosphere crust.
yeah.
but it's weak enough, it's smushy
Yeah, smushy enough.
smushy.
and
Or
soft
not really
and chewy so that you can have convection
Yeah.
going on in there.
Yes, but it's over
This-
like geologic, like long
No,
geologic.
I know
So it's still
not-
like hard.
I know it's
rock.
not bubbling like
Yeah.
my lava lamp, which I
Right.
don't have,
Yeah.
but if I had one,
Oh, I
it
have a
would
lava
be bubbling
lamp.
like that. But that the lava lamp is the great classroom demo
Totally.
for convection,
Yeah,
right?
totally,
So
totally.
you hot at the bottom and the stuff goes up.
What was that, Jim?
I'm just confused because I thought my understanding is poor, but my understanding was that, I mean, there's no plate tectonics on Venus, and I thought that was because the lithosphere of Venus was thicker than Earth's.
Yeah. Yeah. So this
But
is saying it is thicker.
You're telling me it's thinner or non-existent.
No,
I'm
no,
freaked
it's-
out.
it
I
is
don't know.
thicker.
It's thicker but less brittle.
It's less litho.
It's hotter.
Oh.
Yeah.
And like I want to say, right, this is I think I mean I didn't read this in a lot of detail. So correct me if I'm wrong. But
the
like
crust
looking
is
at the
thicker. The
Yeah,
crust
it's-
of
it's
Venus
saying
is thicker
it's-
than
yeah.
the Earth's
The
crust.
article is saying crust and mantle.
Okay.
It's not saying lithosphere and
And
asthenosphere. So
asthenosphere.
I don't know how they're defining
So let's
those
just talk about
rheological
crust
terms.
and mantle.
Yeah.
Okay.
So yeah, so the crusty top part. So like part of it too is like when we think about convection and like lava lamps, you think of like a very liquid thing like the water, and you think of the lava-y or what I actually don't know. I don't remember
Yeah, I
what the
don't know what
fluids
that
are in a
is.
lava lamp. But do you think of the blobby stuff and the more liquidy stuff around it? But like convection in like geology can also be things where you have basically like the lava-y goop and like rocks, and you get like convection of like harder gloops of rock that separate due to differentiation kind of thing, and that can kind of cause convection, right? Like where like it's rock changing form more than like
I mean,
a big liquid
Yeah.
process.
I honestly cannot really visualize convection in
There's a
the
very
Earth's
disappointing
mantle
figure in the
or
paper.
Venus's
The first
crust,
Yeah.
because the convection
I
is
thought it was a video.
I did too. I was like, this should play, right?
convection is heat transport by actual movement of material
Yes.
from one point to another. So
Yes.
it's actual Yeah, that's if that's not a movie, it shouldn't
not.
even exist.
Why
It's
does this
not a
exist?
movie.
Yeah.
Sorry, authors.
So convection
Yeah.
carries heat by actually moving stuff from, say, the bottom of Venus's crust to the top of Venus's crust.
Yeah.
Unlike conduction, where like you're hot on the bottom and that heat percolates through
Yeah.
on a molecular level
Yeah.
to the upper layer. So material stuff is actually moving up, but you can like
a
in this
convection
crust,
cell.
right?
Yeah.
And you can walk around on the surface of Venus. It's not a gooey surface.
Correct.
Right.
Correct.
And so it's moving, but it's on geologic timescales.
Mm-hmm.
I can't really wrap my head around it and create a mental image that, I mean, we can look at these pictures and like show
Mm-hmm.
these things like that just looks like what we draw for the Earth's atmosphere.
Right. Yeah. It's very, very slow. And because of the temperature domains, we're still dealing and pressure, we're still dealing with mostly hard rock, but things are just it's called creep, where you have like there's bonds and then they kind of just like
Shift.
like that.
Yeah.
But very, very I
Well-
know that's great for a podcast.
well,
but
we
like
see-
You could like visualize it as something like glass, right? I mean, glass seems very solid, but
But
if
it
you
flows.
it's
Yeah.
technically
very
it
long
flows.
timescales, it
yeah,
flows.
and exactly. And at any moment that you like touch glass, it's a hard
It's-
thing,
right.
but it is flowing over very long
Well,
amounts of time.
Another thing that we see convection-y type stuff and sort of what I think you were referring to in Arctic regions in permafrost, where there are thermal cycling that causes rocks to shift. It's maybe not really truly convection because I don't know if it's driven by thermal stresses, but I don't know if it's driven by like heat underneath, like that kind of differential. But on Pluto, we see features on the surface that look like the
Yeah.
tops of convection cells in solid nitrogen, which is just
Yeah.
awesome.
Yeah.
Solid air. So cold, the air is like
Yeah.
slush.
Wild. Yeah.
Cool. States of
crazy.
matter.
Yeah. That's
Yeah.
pretty crazy.
Yeah. So that might be going on Venus. And I think they were saying right now it's hard to verify it with the data that we have of Venus, but hopefully with the upcoming missions there can be better data of topographic
Da Vinci
regions
and Veritas.
Yeah, and like different gravity anomalies.
Yeah. Before we get into cosmology,
Jim's here.
Yay!
let me drop the trivia on
Okay.
you folks.
Don't hurt us.
Yay!
Because it's sort of it's a space flighty travel, so it's sort of related to our stumper and
Whatever you did well the last time, Jim.
yeah,
Shut
you-
up.
I did. I dominated.
You
the last one.
dominated the last one of these. This is musical. I'm thinking about music a lot and live performances of music a lot these days. So that's our trivia. What is the first song played by astronauts on musical instruments while in space? So it's sort of convoluted, but it's
Say that again. What is the first song?
played by astronauts where they actually were playing an instrument instead of like playing a recording of a song.
I see.
Okay. And what were the instruments? And that's part A
This should have been the
/1.
trivia question when we had Katie on.
Astronaut Katie Coleman.
Astronaut Katie Coleman.
Yeah, it should have been.
Oh well.
It could have been. Shoulda, woulda, coulda.
Next time.
She did get a musical trivia. We did have a musical trivia for her. What was the first musical instrument on the International Space Station? That's part B/2. Which of the following instruments, this is getting back to this mode of question that Addie reminded me I haven't done in a long time. Which of the following instruments has not been on the International Space Station? You have 6 choices. All of them have been up there except one. An electronic keyboard,
Okay.
a lyre,
You're a liar.
man, alto saxophone, a didgeridoo, bagpipes, and a piccolo. I didn't mean to go. didn't mean to go piccolo.
Piccolo, testing
Some
out
of
your
these
new
I
mic.
Piccolo.
feel
I
bad
don't- I
for
don't
the
have a
other.
Pop guard on this mic, so it's going to sound
pop
terrible.
filter.
Yeah, pop filter.
Pop-up video.
And then finally, part 4/D.
Oh my gosh.
What was the first song recording that was played on the surface of the moon? That one's also multiple choice. I'll give you those choices when we get to the end.
Oh my gosh.
All
I already
right.
forgot the first question. It's okay.
That's okay.
I'll
You're gonna
remember
hear
it
it
when
again.
we hear it again.
You'll remember it when I tell it you again.
Okay.
I tell it you again.
Tell it us again.
All right, Jim. Cosmologist us away.
Speaking of changing things, as we were talking about changing on Venus, DESI, that's the Dark Energy Spectroscopic Instrument, which is basically just it's a camera kind of thing set up on an already existing telescope that does a lot of collecting. Basically, it's like trying to map out
Photons.
the universe in 3 dimensions. Was that?
Does it collect photons?
It collects photons.
Yeah.
Yes.
Great.
I get it
and
now.
It's measuring both. It's measuring in 3 dimensions the positions of all kinds of crap that's out there, and that is super helpful, right? When you're
There's
trying
so
to
many
figure out.
so many things, like that's what Gaia did, and that's what this other thing that we were talking about, the big structure or whatever, also did.
Right. So it's doing that.
Yeah.
But I mean, Gaia was doing it on small scales, like
Right.
in our galaxy.
Within the
This is
galaxy.
doing it.
Cosmologically.
Right. This is doing it in cosmologically. To look for, we know about this filamentary structure of the galaxies and dark matter and all this stuff, but we need to know a little bit more, like exactly how big are the gaps and how far apart are the filaments and all that kind of stuff, because that tells us about the early universe and the evolution of the universe. And in a nutshell, what they have seeming to maybe start to be finding is that our ideas about dark energy might be wrong.
No.
How many
How can
ideas
that be?
do we have?
That was going to be my question.
yeah, same page.
Aren't we always
How many
like, we
what?
don't know what dark energy is?
I thought we had 0 ideas about what
We have
dark
lots of
energy
ideas.
was.
Well, we're wrong in that. We have one idea. And Jim is going to
No,
tell us
well,
about it.
when I say that, I mean, so we don't know what it is, but we thought we had a reasonable handle on how it behaves. That is, the standard cosmological model, like we've talked about, is this Lambda CDM thing. The Lambda stood for cosmological constant, which is a specific kind of dark energy. We don't know what its kind of origin is, but we know how it behaves, or we thought we knew how it behaves. But DESI is hinting that maybe it hasn't always been a cosmological constant. It's been a different weird thing earlier in the universe, and it's transitioned over to something that looks like a cosmological constant.
So it's not a constant? Because
might
it's
not be
not constant.
But
There may be, I think the easiest, I think it could be just more than one thing. There could be several components to dark energy out there, and one dominated a little earlier in the universe and one dominated now. Having said all that, I mean, this is not at a huge confidence yet. I think it's like 1.7 sigma is the
cosmologists and their sigmas.
Their
Right,
lambdas and
right.
their sigmas.
Yeah. Like
what we mean by that is, that the chances that you could
the signal is
that
small.
it's different from the typical model. We need it to be very different from the standard model to be confident that it's real. That
Well, it doesn't need to be
usually-
very different, but you need to have a good signal of noise to determine a
right,
small
right, right.
difference.
You need to be very sure that it's different. So we're not usually 3 sigma or 5 sigma is the gold standard of I've made a discovery about something, and this is 1.7 sigma. So this is just like
Is
a
3
hint.
sigma
Well,
the gold
something might be
standard
wrong.
and 5 sigma is the platinum standard?
That's right.
Yeah, maybe something like that. Yeah.
I mean, it's kind of like if you see 3 people and they're 5'10", and then you see another person who's 6'1", what's your confidence that they're from a different population? It's low, but it's they look maybe different. But then if you see 300 people who are 5'10" and 300 other people who are 6'1", the difference is still small, but the signal to noise is much higher, so you're confident that those are different populations.
I think I
Yeah.
understand what you said. Wait,
The
so
chances that I've got a population of 4 and a variation of a couple inches is whatever. That's not distinguishing. But if I've got a whole group, then they're all 6'1", and I've got hundreds of those people, and I've got another whole group with hundreds of people that are 5'8" or whatever, 5'10", I said.
But which one would win in a fight?
Me.
Depends on what kind of fight. Is it basketball?
It's, who can
A
jump?
basketball fight?
Classic. All right. Anyway, Jim, back to the cosmology.
Okay, is it jabbing?
Will the sigma
So,
go up if they
I want to
observe
be
more?
so this is one of these things. Like
I apologize
you
for
always
my
see
metaphor
headlines-
for analogy.
You always see headlines. 5'8"
do.
is also, by the way, very tall. I'm always the you always see headlines like, cosmology is busted. Like we have to go back to. This is not a thing where we have to go back to square zero. Or
I saw
like
that this is a bombshell.
Yeah. Which it a little bit to cosmologists it's bombshellish, but it's not. It's not going to change anything radically. It's just going to change things a little bit.
Okay.
I mean, even if it's
true.
confirmed, it's only going to
Even
change
if it's
things a little
concerned-
bit.
Well,
So
That's not what I was getting from this thing, because the lambda is famously Einstein's cosmological constant, and
Yeah.
it acts like a pressure on the expansion of the universe in some
Right.
simple-minded way, right?
right.
And constant means doesn't change, right?
Right.
And these new observations say that whatever the extra expansion of the universe was has been changing.
Right.
So that means it's not lambda anymore. It's not just this constant of integration that Einstein put in there when he integrated his equations, right?
Right. That's
So
right.
that seems like a pretty big frickin' deal, Jim.
it's not a constant. It's a variable.
Right. But the amount of change, let's not overblow the amount of change.
Oh, I'm
This is very-
overblowing it.
This is a huge deal.
I mean, that's
Bombshell.
kind of like saying, well, Mercury's orbit due to general relativity isn't that much different than it is from Newtonian, so don't make a big deal out of it. But it actually is a big deal because general relativity describes gravity in a completely different way than Newton does.
It's going to make a big difference to Audrey when she's there
Yeah.
4.4 million years ago.
Yeah. Think about
Right.
me.
So it does. The difference between general relativity and Newtonian gravity doesn't make a very big difference when you're looking at the orbits of planets around stars. It does if you're near a black hole or something like that.
Right.
This is not going to like all of a sudden mean that we were wrong. The universe is 40 billion years old, or it's 100 million years old, or something like that. It's not going to change anything that much. The rate.
Okay, but it's going to fundamentally change our understanding of like what the F is going on, isn't it?
In a sense, it's not going to change. Like Lambda CDM has been very, very good at making a lot of at matching data very, very well. So
Like
any
Newton
difference was that
was like Newton was.
right? Exactly. So any change isn't going to be radical for the things that we're looking at. I think maybe where it will be a big change is like what is the eventual fate of the universe? Right? If you ask a question like that, that depends very critically on what the nature of this dark energy is. But how things have changed in the past and how things are changing in the nearest future will not be very different.
Right, but the nature of what is going on in the universe
Changes.
could be fundamentally different than what we think it is.
Jim
I don't know.
disagrees.
I don't know. Well, I don't think it's a sea change. I mean, if you're for those in the know, for those in the know, it's just like it's a change in the.
Those in the know. Sorry.
Meaning like you. No, meaning like you. Meaning like you, who has
It's what?
studied. It's a change in the equation of state, but only by a little bit. So it's a change in the,
Yeah.
So yeah, I
Okay.
mean, I think it's interesting.
I'm going to let it down. I'm going to let it drop. I'm
The
going to let it
article
go.
talks about it, right? And it makes it so we're talking about dark energy, and it's dark because we can't observe it, and it's this mysterious thing. But then it talks about it being phantom dark energy early on, where it existed, but you couldn't have even detected it, right? Basically,
right. If like all of the dark energy was this phantom dark energy is horrifying, by the way, because if all of the dark energy turned out to be phantom dark energy, then our universe would end in what's called a big rip. Which would mean like an accelerating expansion that's getting faster and faster and faster and faster, and then at some finite time in the future, the universe would become infinitely big.
but that's not happening.
That's not going to happen because it seems like there might have been some phantom energy, but it's gone, and now
Gone away.
now it's
I just
more
have to
like a
say, the other
cosmological
thing,
constant.
Sounds like a sea change to me.
I don't. Well,
I was reading the article about this, and it talked about, so the measurements they're taking are from baryonic acoustic oscillations,
yeah.
um,
Oh yeah,
which are called BAOs or
Yeah.
bow.
Right,
And
delicious.
It made me hungry.
Oh,
and
so
then it
good.
talked about the
So
bow
good.
getting bigger and expanding, and I was like,
Yeah.
oh, I want that in my mouth.
steamy, tasty bows are
Yeah.
steamy.
Yeah.
Why'd you look at me like that for?
It's
Did you
just,
think I was going into a sort
I
of
wasn't sure where you were
porn
going.
direction or something?
I don't know.
You never know.
Cool. All right.
Yummy.
Well, I'm disappointed with your reaction to your own story.
I'm excited that there's no big rip, but also that this is cool new data.
Yeah.
It's very cool. Don't get me wrong. It's very cool. I just,
Yeah.
I just don't want the general public to go thinking, oh, we have to start over from scratch. It's not that, right? It's
I don't think there's any concern about that happening based
No?
on this podcast.
Okay.
Mass hits. It's going to be in the Wall Street headlines of the New York Times next week. Public questions everything. We must start over after radical announcements on Walkabout the Galaxy.
So many things.
Everything
so
must
many
be
things
thrown
would have
out.
had to
We
be-
must start from scratch. People throw themselves from windows because podcast announces sea change in our understanding of dark energy. Yeah.
It'd be fun
Yeah.
to know how much influence.
Please
Calm down,
keep yourself
everybody.
safe, everyone.
Keep yourself safe. It's all good. This is an exciting,
Don't get
happy
too
change.
excited.
It's a happy
Yes.
change. There's
Yes,
no
this-
big rip.
Yes, that is good.
Good. It's a good, happy, exciting change.
Yeah. No
just
big rip.
just like general relativity was.
Oh,
All
such a
right,
good.
bring us some trivia.
Yeah. What's the first song played by astronauts on musical instruments in space, and what were those instruments? So if you get any parts of that remotely right, you get 750 points.
Yesterday by the Beatles
On what?
on a keyboard and a flute.
Oh.
A keyboard and a flute they played yesterday. When do you think that might have happened, Jim?
I have no idea.
Okay.
Yesterday was written in like this 1970-ish or something. So maybe that's a stupid answer.
Well, it existed.
Why is that a stupid answer?
Yeah.
I don't know.
People can
Because
play it now.
people went up into space before then.
That's
I don't know. I'm sticking with it.
Okay.
I think something like "Happy Birthday."
Okay, that's I like that
On a
answer.
harmonica.
Love it.
That's smarter.
Time frame?
I don't.
Not even going to say a year
No,
for
because I'll
fear
get
of embarrassing
ridiculed.
yourself.
Yeah.
Yes. Okay.
Just because it's 1872.
1730.
Every fool knows Happy Birthday was written in 1819.
Oh my god.
All right, Addie, what do you think?
I actually have no idea.
Okay.
I like something like Happy Birthday. I'm gonna go with
Happy Birthday is wrong, but it's on the right kind
you
of.
know, with like a Christmas song.
Yes.
Oh, I was.
It was a Christmas song.
Yes. But I'm trying to decide which one because I can't because I thought of a Christmas song. Now I can't think of literally any Christmas
Jingle
songs
Bells.
other than like Jingle Bells
It was Jingle
with
Bells.
like bells
Oh.
It was Jingle Bells with bells. And
Nice.
a harmonica.
and a harmonica.
Jingle
Yes.
bells. Jingle bells with bells and a harmonica. So the
Yes,
two of you,
teamwork.
Nice.
nice.
You guys killing it. Nice.
Framework.
Wally
I'm redeeming
Schraw,
myself.
Wally Schraw and Thomas Stafford on Gemini
Oh,
6.
cute.
It was in December of 1965.
Yeah, there were a couple missions that happened around Christmassy time.
They sneaked those instruments up. They weren't supposed to have them.
I was gonna
Little
say
Jingle
it,
bells.
it probably had to be something small because back in the day they were
Yeah.
pretty mass constrained.
What was the first musical instrument on the International Space Station? So during Mir and the earlier missions, sort of like in the 80s, they
The
learned
didgeridoo.
they learned that musical instrument was a real boost to astronaut morale
Oh,
on
okay.
long duration space flights.
Like I'm gonna go with like a guitar, but I feel like a little electronic keyboard is a better guess.
Maybe
Violin.
Like
Oh,
nice.
Jim.
Violin.
I was thinking like
You're laughing at my answers. This
You
is not
laugh
good.
at your
This is not good for me.
I am laughing.
This is
like
not good
a-
for me.
Just the idea that
How it
somebody
would be
who,
really hard to play a violin
why?
in weightlessness.
just the idea
There's
that
a lot
like,
of like
you use your
motion.
shoulder to
listening to a solo violinist is going to be a mood booster. I don't know. It's just a little bit.
thinking like ukulele, but
Oh, I
that
like
might
that.
be too big. Maybe harmonica. I'm gonna stick with ukulele.
Yeah, it is an acoustic guitar. Which of the following instruments has not been on the ISS? A keyboard, a lyre, a saxophone, a didgeridoo, bagpipes, or a piccolo?
Back bagpipes?
I hope bagpipes have not been on the ISS.
I was going to say bagpipes also. They're huge, right? Those things
We
are
all just
huge.
got trolled.
Yeah, it's lyre.
You're a liar. I knew it.
At least I could
see what you did.
At least I could find no evidence that a lyre has been on the
A
space station.
didgeridoo.
But the others, you know who made the didgeridoo?
Our friend we just talked about, whose name what's wrong with my brain today?
Friday afternoon brain.
It is Friday
Don
after
Pettit.
Don Pettit. Thank
Yeah,
you.
he fashioned a didgeridoo out of
Of
like
course he did.
Oh,
out
he
of,
didn't
like-
bring it up. He made
he
it.
made one.
That's
yeah.
incredible.
Out of like
Awesome.
vacuum
Google this.
cleaner parts
Can
or
we play
something
this?
like that.
We're gonna put this on the Instagram.
Okay,
Yeah.
we'll put it on the Instagram.
You know, we always say that we're going to put it on the Instagram, and we only do that like 20% of the time.
I get to it at some point.
Yeah, 20% of the time.
Yeah.
What was the first song, this multiple choice, what was the first song recording to be played on the surface of the moon? Ready? Fly Me to the Moon by Frank Sinatra, Blue Moon, Irving Berlin, Moon River, Henry Mancini and Johnny Mercer, Space Oddity, David Bowie, or Reaching for the Moon, Irving Berlin. First song as a recording played on the surface of the moon.
Frankie.
Bowie.
Blue Moon.
Sinatra, David Bowie,
Bowie.
and Jim,
Blue
what'd you
Moon.
say?
Blue Moon.
Blue Moon. It is Fly Me to the Moon.
Wow.
Yeah. Fly Me to the Moon. Space Oddity, the David Bowie, and then,
That's been played on the ISS.
right. This was actually, I did not know this, was rushed out as a single days before the launch of Apollo 11.
Really?
So that it would sort of, I guess, to kind of have it coincide with that mission. Which I
Beyonce's
did
gonna
not
do one of
realize it.
those.
Yeah.
Good for her.
Yeah. Jim, next time will you tell us about this new black hole model that's got avoids the singularity?
Yeah, sure.
Okay. All right. Tune into episode 392
Ooh,
for some hilarity
cliffhanger.
about
Cliffhanger.
black hole singularities. I kind of hesitate to say this, but it's what I wrote, so I'm going to say it.
Oh no.
While it may have felt like standing in line for a Rolling Quartz concert, it was just another episode of Walkabout.
Who's
the
Rolling Quartz?
Oh no.
Is that his
Rolling
new?
Quartz.
Is that his favorite new
K-pop.
K-pop band?
Pop. Yep.
Jim, you could
Okay.
have gone to see them in Montreal just a couple days ago.
You could have.
Oh man.
Jim secretly
Okay.
did.
Yeah, they're playing in Boston tonight, New York tomorrow, Philadelphia, and then
Oh, man.
Orlando.
I don't know if you knew that Josh is now their PR rep.
I didn't know that, but that's awesome. Go on with your bed
even-
stuff, Josh. Okay, I'm sorry for dealer rant. Go ahead. It was just another episode of
It was
Walkabout the
just another
Galaxy.
episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Do you know what our endings sound like to me now? Have you ever seen the movie Noises Off or the play?
No.
The play goes disastrously wrong, and they're like desperate for the curtain to come down, and they're all like, "What's the last line? Say the last line," so the curtain will come down.
Usually
Like
we're
that.
very smooth.
Yes, it was just another episode of Walkabout the Galaxy. Go again, Audrey.
Okay.
Well, she did just fine.
But I interrupted it after it, so we
Yeah.
need the flow again.
Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger.
Thanks to our listeners in Norway and around the world. I'm Jim Cooney.
I'm Audrey Martin.
I'm Addie Dove.
And I'm Josh Caldwell. We're the astroquarks, signing off until the next episode of Walkabout the Galaxy.
Barka barka barka.